This video is for topic 9.3 over solving systems by substitution. We are given a system of linear equations and asked to use substitution. In a similar manner with substitution, just like when you have a substitute in the classroom, your teacher is no longer here, your teacher leaves, and someone else comes in their place and replaces them for the day. We are going to do something similar. Problem 1 has already mostly been done for us. What they did was first they solved for x or for y, and in all of these cases today, you are going to have one letter by itself already. So in this case, y is already by itself. In the second equation, instead of writing the letter y, we are substituting the letter y with what y equals. Y equals x minus 3. So we rewrite this original equation, but instead of writing y, we write what y equals. From here, we solve for x. We combine like terms, move the 3 to the other side, and divide. Once we know that x equals 7, we can solve for y. We then substitute 7 instead of x. We replace x with 7. 7 minus 3 is 4. When we write our solutions, we write them alphabetically, x and then y. So 7 and then 4. So this one is partly done, but we still have some stuff we have to do. Looking at my equations, I am looking for one where y is already by itself. So I quote solve by rewriting an equation where one letter, x or y, we have x equals or y equals, is by itself. From here, we use the other equation, 2y equals 5x plus 8. So this is the top equation, the one we did not just identify over here, goes in the middle box. Instead of writing what y equals, we are going to substitute y with 3x plus 4. Notice that everything except for the letter y stays the same. 2 stays the same, 5x plus 8 stays the same. From here, we have everything in terms of x's or numbers, so we can solve. In order to solve, we distribute 2 times 3, and 2 times 4 is 6x plus 8. And then they have finished this problem out for us. They move the 5 so that this cancels. And then they move the 8 to the other side, and we get that x equals 0. If you get a 0, it does not mean that you have messed up. It just means it is crossing when x is 0 and y has another number. Remember, on a graph, they could be crossing here where x is 0 and y is like 8. I don't know if that's what this problem does, but whenever they cross, getting a 0 is not wrong. On the plug and chug, we are going to plug back in. Instead of writing what x was, we write what x equaled. X equaled 0. 0 plus 4 is just 4. To write our solution, we write our x and our y. So this crosses at the point 0, 4. For problem 3, we have an x equals, and x is already completely by itself on one side. So that is the equation we are going to use for the first part. Our second equation goes in the middle. With our second equation, we rewrite, and everything stays the same except the one letter that is by itself over here on the left side. So because I have x by itself, instead of writing the letter x, I am going to substitute in for what x equals. Now my equation is all in terms of x's or y's, so I'm going to distribute. 3 times 2 is 6. 3 times negative y is negative 3y. The plus 2y and the 36 stay the same. I'm trying to solve for y, so I combine my like terms first. Negative 3y plus 2y is a negative y. I move this 6 through subtraction. So negative y equals positive 30. Divide everything by negative 1, and y equals negative 30. I am going to take the value of y and replace it on the right side. I know that x is 2 minus the value of y, so in order to solve for y, I replace y with the value of y of negative 30. Minus minus is really a plus or a positive. 2 plus 30 is 32. So I write my answer as 32 and 30 because 32 is my x, 30 is my y. There is a time when you have two equations that are both solved for one letter. I have y equals and y equals completely on its own over here. And I could pick one equation or the other equation. It doesn't matter. What you're going to do is instead of substituting one into the other, you're going to substitute the other two pieces. So over here in the middle, we have the top equation equals the bottom equation, and we have not written the y equals because we replaced them. From here, all we have to do is solve for x, so we subtract x from both sides and get that 2x equals 4. Divide both sides by 2, and x equals 2. Once I know the value of x, I can solve for y. I know that y is 3 times the value of x. I know the value of x is 2, so y would be 3 times the value of 2, which is 6. So my solution, x is 2, y is 6. Problem 5 is a problem that comes up a lot on the EOC. They tell us that we have a length that is 5 more than twice the width, and then the perimeter is 190. And so they've already started this problem for us. The length L is 5 more than twice the width, so L equals 2W plus 5. And then our perimeter is 190. We remind ourselves that perimeter is 2 lengths plus 2 widths because we add up all the sides, and that equals 190. W is going to represent our width, and L is going to represent our length. They ask us to write this system of equations. This equation has already been written for us. The other one we need to write is that L equals 2W plus 5. Now, for my first box, I have a letter completely by itself, so that's what I need to put in my first box. In the second box, they have already written our second equation, and we replace L with 2W plus 5 because those are the same things. From here, I solve for W, so 2 times 2W is 4, 2 times 5 is 10. Combine my like terms, so 6W plus 10 equals 190. Subtract 10 from both sides, so 6W equals 180. And divide by 6, so W equals 30. In order to solve for the length is 2 times the width plus 5. My width is 30, so I am replacing W with 30 and keeping everything else the same. 2 times 30 is 60, plus 5 is 65, so my length is 65. To write my solution, we write them alphabetically, so length is 65, width is 30. So to summarize, you are looking at the beginning for one equation that is already x equals or y equals. From there, whatever letter you have by itself is the letter you substitute into the other equation, solve for the other letter, and then plug back into the equation you used on the left to find your final answer.